Okay, so today is March 16th. We're doing 3.3 and 3.4. You need to have this ready in class. We need more time in class to do some work. We need more time in class to actually do these experiments. So you need to have your homework done on time. So 3.3, square a circle to find its area. So we're going to use squares to find the area of a circle. Square a circle to find its area. 3.4, connecting circumference and area. So how are circumference and area related? And that actually is your focus question. We're on page 48 in your notebook now, page 48. Okay. 3.3, square a circle to find its area. Our focus question is, what is the relationship between the area of a circle and its radius? So this green part, this radius, how does that relate to the area of a circle? You have the 3.3 lab sheet. We handed this out in class. We cut out 3.1 and 3.2. Those are the only copies I have. So I will post a copy of the lab sheet there online again. It's still on the other link. So if you need another copy because you threw it away or didn't keep it like I asked you to in class, you need to print it out and put this into your notebook. Okay. So this needs to get cut out, and what we're actually going to do is we're going to do this experiment in class. So if you don't have this in your notebook, you're going to have a hard time. So you need to know that we're actually not concerned with the circumference in this question. We're concerned with the area of a circle. So how much space this section is worth, how much red space there is in here, and we're going to connect that idea to the radius. Okay. Now, a couple of things here before we get started, and I'm going to ask you these questions in class. What does this represent? And let's do this in the same color. What does this represent? Okay, from here, from this point to this point, this is our radius. Well, if that's our radius, what is radius times radius? And what shape does that make? A radius times radius. Well, radius times radius makes this section a radius squared. Okay, so you can go ahead and label this section radius squared. Radius squared. That's this section right here. This right here, that's a radius, and this is a radius. Radius times radius gives me the area radius squared. So we're going to use this section to figure out how many of these sections it takes to cover this entire square. And how much left over will we have? Okay, how much left over will we actually have? So I'm going to pause it, and what I'm going to do is I'm going to cut out this section here. This section, I cut out this section, and we'll see how much we have left over. Okay. So what I'm going to do is I'm going to actually, let me get this part, delete this arrow so I can color it in. What I'm looking for is how much of this do I need? How much of this do I need to cover this circle? And I'm going to actually create a full square all the way around it. Okay, so I'll show you what I'm talking about in just a second. Okay, so this took me a long time to color, so please bear with me on how beautiful this is. I'm going to zoom in here a little bit more so we can see the circle 1 a little bit clearer. So it says circle number 1, and we need to figure out how many of these whole squares do we need. So when I'm talking about whole squares, I'm talking specifically about how many of these squares do we need. We call this a radius squared. Remember, this is a radius squared. How many of these do I need to cover this entire circle? Okay, well, I don't want to use any of the extra. Okay, so I'm only going to use these radius squares. So what I'm going to do is I'm going to duplicate these sections so you can see what they look like. So this one, so far, that looks like 2 radius squares. Now remember, I don't want to use the blue section. The blue section doesn't technically count. I'm not using those squares. Okay, so if I use all of these, I used 4 squares total. correct? So I used one radius square here. I used one radius square here. I used another radius square here. I used another radius square here. And lastly, another one here. So I used 4 radius squares. What I'm going to do is I'm going to subtract the parts that I did not use. Okay, so the parts that I did not use, I'm going to subtract away. Okay, so what that means is I'm going to break this up and see how much I didn't use. I didn't use this section. I didn't use this section, this one, or this one. So let's put this all together and see how much that actually represents. Okay, so I'm gonna zoom out a little bit so I can get all this into one shot. Okay, if I didn't use this radius squared, and let me turn this a little bit so that way, okay, well, that's how much I didn't use. I didn't use this section here. Okay, so, and I didn't use this section here. So how much does this represent? Does this represent a whole nother square? So do these sections together represent a whole square? So does these two, they represent a whole square? No, not quite. So let me put this here. So I've used 4 minus this section here. So I know it doesn't really exactly fit in here. And usually in our lesson, what we do is we actually chop this up into small pieces and fit them in there the best we can. So what you'll notice is we used about 3. We didn't use exactly 4 pieces. We didn't use 3 pieces. We used a little bit more than 3 pieces. Okay, so what we're actually using is we're using about 3 and a little bit more. It's kind of hard to tell because these 4 pieces don't actually chop up to make a whole rectangle here. I can't cut them digitally, but what you notice is if I put them in there the best I can, will this section here, will this section right here, if I cut this out and I put it in there, if I cut this section out and I put it right there, I still have a little bit more that I didn't use, and these parts are actually being used to cover this circle. So what we're going to do is the number of radius circle units will fill this all out. Okay, so the radius of the circle, so circle 1 has a radius of 1, 2, 3, 4, 5, 6. This one has a radius of 6. The area of square units, so a 6 by 6 square, 6 by 6, what a square means we're using 36 square units. The area of the whole square, let's see how much squares we actually used. I'm going to count up how many squares we actually used, and I'll write it down for you. So I counted all these little pieces in here, and we used about 113 little squares. 113 little squares to cover the entire thing. So the number of radius squares, that means how many of these red squares did we use? We used a little bit more than 3. So I'm just going to write in here a little more than 3. Okay, more than 3. I'm going to stop there and we'll do these 2 in class. Okay, we'll do these 2 sections in class, and we might even do circle 1 over again, and it's just a little bit messy. Okay, here is 3.4, connecting circumference and area. Again, you don't have to write this section. This is just a reminder of the things that we're talking about so you don't forget what those important things are. Our focus question is, what is the relationship between the circumference and area of a circle? Okay, so what do the outside, the black circle around this here, what is that? And the area, if I fill this in, what do they have in common? Okay, so how does that connect to this? Now, you don't have to, we're going to do this experiment in class. Again, it's a lot of cutting and a lot of gluing, but hopefully it'll make some sense. So what you'll notice right now is I'm going to mark the outside of this circle. So, and I would recommend doing this with a highlighter. Actually, let's do that with a highlighter instead. The the outside of this circle. Now the outside of this circle, okay, actually makes this one big loop, and when we cut this circle up along the lines, okay, and you know what, I'm gonna just do half of this. Let's do half of this. This half here, okay, will actually be represented in this section here. That is part of this yellow section. This red section here, 1, 2, 3, 4, will match these 4 sections down here. 1, 2, 3, 4. Now, this question here, I'm gonna write this out at the end, but what does this shape begin to look like? This starts to become more and more like a what? Okay, that's one of the questions we're going to be talking about. It's one of the questions I'm going to ask you to answer at the end of this section. Okay, so you need to have this part filled out. Make sure you have your connecting circumference and area. You can glue in this circle parallelogram section here if you want to go ahead and print it out, but I will have this copy in class. But I do want you to know that this yellow part is this first half, top half of this shape, this parallelogram, and this pink part is the bottom half. And as we lay them together, it gets closer and closer to a what? And this is what we're going to be talking about in class. So how does the circumference relate to the radius? Well, is there another section of radius on here? Where else can we find the radius in this shape? Okay. Here are some of the questions I want you to answer that will help you think along the way, will help make sense of our lesson of 3.3 and 3.4. Again, this lab sheet will be ready in class. You should have this copied down so we don't have to worry about wasting our time in class to get this done. Again, I'm going to talk about the circumference of this circle, how it relates to this shape, and some questions and some things to think about in your summary. In your summary, what do you think is a little more than 3 referring to? Now that's referring back to 3.3. Now here we're talking about what does a little more than 3 refer to? Okay, what do you think this means? We've talked about this before, and if you're not sure, it was in Dragon of Pi when he was trying to put the crust on the pie, when he was trying to measure around the circle of the wheel. Okay, what does this represent? Okay, in 3.3 again, what does when have we talked about radius squared before? Radius squared, this is what it looks like. This is what it's spelled out like. When have we talked about radius squared? So we see it here. Where else do we talk about it? When else? In what section do we talk about it? And we were talking about radius squared. What were we talking about? Okay, it talks about the area of radius square units. Okay, so radius square shows up here, it shows up here. Where else do we talk about it this week? Last class. Okay. For 3.4, the circle, when the circle's cut into smaller sections, what shape does it make? So what shape does this make? Okay. If you cut it into even smaller sections, so instead of 8 sections, let's say you cut it into 16 or 100 sections. If I cut this into 100 sections, will it still look like this, or would it look different? And what is the height of the shape that is created? So if I cut this into 100 shapes, 1,000 shapes, 1,000 even sections, and I put them all like this, what section will it look like? What will the height be, and what will the width be? Based on this drawing, okay? And we'll cut this up in class, and we'll glue them down so we can see what it looks like, okay? Make sure this is done before class, okay? Very important that we have this completed before class.